Okay, ladies and gentlemen, this is going to be our last example, or our last short video to finish up section 1.3. The problem that you see here, we have 3 times 6 minus 2 cubed in the numerator, and in the denominator we have 14 minus 3 squared. Now remember, hierarchy of operations, what you do first. Some of you have heard, please excuse my dear Aunt Sally. Do what's in parens first. Then you do exponents next. Multiply and divide in order from left to right. And then finally add and subtract in order from left to right. It's a great little mnemonic device. So in this particular problem, 2 to the third becomes 8. Notice I did that first. 3 to the second becomes 9. Now the next part of the problem that I would do, 3 times 6 is 18. And then we're going to finish the problem by doing what the numerator and denominator now say. 18 minus 8 is 10 in the numerator. 14 minus 9 is 5. And 10 divided by 5 gives me the final answer of 2. So, please excuse my dear Aunt Sally is a very good way to remember hierarchy of operations. If I look at this next problem, the square root of 3 squared plus 4 squared. When you're dealing with a radical, in this case the square root, one of the best things to remember is to do what's under the radical first. So in this particular problem, 3 squared becomes 9, 4 squared becomes 16, 9 plus 16 is 25. Now the correct step to finish the problem is to evaluate. The square root of 25 gives me the answer positive 5. So with radicals, you want to work what's under the radical first, as though it were all by itself. Work it all, get that answer, and then apply the radical to it. Okay, my next example asks me to take a number. Well, in this case, 38 million. So it's 380, comma 000, comma 000, and to write the answer in scientific notation. If you recall with scientific notation has to be written, first of all, as a number between 1 and 10. So in this problem, we start with 3.8. And the second part of scientific notation has to be 10 raised to some power. So you're going to multiply by 10 to a power. Notice where I currently have the cursor. It's right between the 3 and the 8. If I move that decimal place 8 spots to the right, that would put me back to where it belongs in the original number. That's why the power I use on the 10 is a positive 8. So my final answer would be 3.8 times 10 to the 8th. A very good rule of thumb. If your exponent on the 10 is positive, you're dealing, especially the bigger, you're dealing with a fairly large number. That would be a really nice bank account, wouldn't it? Okay, on the next one, we have 8.56 times 10 to the negative 4th. Now, the directions say write the answer in standard notation. 8.56 times 10 to the negative 4th is already in scientific notation. We're trying to write it how it would be without being in scientific notation. That's called standard notation. 10 to the negative 4th, multiplying by 10 to the negative 4th, basically is telling me to take the current location of the decimal and move it 4 places to the left, thus giving me the answer 0.000856. So a very good rule of thumb, when you're using scientific notation in either direction, when the power on the 10 is negative, you're dealing with a small number in standard notation. Okay, perform the following operations and write the answer in scientific notation. 4 times 10 to the negative 12th multiplied by 2 times 10 to the 15th. Pretty simple to do if you kind of break it up into parts. The 4 times 2 gives me the 8. 10 to the negative 12th times 10 to the 15th. We leave the base of 10 alone. Remember, when you're multiplying, you add exponents. Negative 12 plus 15 is 3. So as my answer, I have 8 times 10 to the third. Now the directions on this problem asked us to write the final answer in standard notation. They did not want us to leave it in scientific notation. So that's why I write my final answer as 8,000. Another problem that says perform and write the final answer in standard notation. In the numerator we have 26 times 10 to the fourth. In the denominator we have 2 times 10 to the negative third. Let's digest this. Let's break it apart. Let's analyze it. 26 divided by 2 is 13. Got that? That's simple arithmetic. Nothing fancy. 10 to the fourth divided by 10 to the negative third. When you're dividing, remember what I've taught you. Laws of exponents say leave the base the same, so 10 is not changed. When you're dividing, exponents get subtracted. Top minus bottom. Top exponent is 4 minus the bottom exponent is negative 3. 4 minus a negative 3 becomes 4 plus 3, which is 7. We end up with 13 times 10 to the 7th. Because our answer asks for standard notation, we move that decimal behind the 13, 7 spots to the right, and wow, we end up with a big number, 130, comma, 000, comma, 000. Again, a very nice bank account, right? Okay. Find the area of a square if one side of the square has length 9x units. All right. Remember in math, square. If I just said to square something, you know you're raising it to the second power. So kind of a little clue on finding the area of a square. You take the length of one side and you square it. So in this case, to find area A, I take 9x, I put parens around it, and I square it. I put the 2 on the outside of the parens as an exponent. The whole thing is being squared. 9 squared is 81, x squared is x squared. My answer is 81x squared. You need to also make sure you're using the correct units. Remember, when you're finding area, it's like if you were carpeting a room, you would be, your units would be square units, like square yards. In this case, we're just going to say square units. Since we don't know whether it's square feet, square inches, square miles, we just don't know. On the next example, it asks us to find the volume of a cube if an edge of the cube has length 2 ABC units. Okay, to locate, or to find volume rather, remember, cubing something in math in general tells you to raise it to the third power. So that's kind of a little clue here. If you want to find the volume, you take the length of one of the edges, 2ABC, put it in parens, and raise it to the third power. 2 to the third is 8, and then of course we get A cubed, B cubed, C cubed, and this time, since you're finding volume, your answer is in cubic units, not square units. And it's very important to put that. You know, when you're finding area, make sure you're giving the correct units for your answer, square. When you're finding volume, like you were, for example, going to Sears to buy a refrigerator, if you bought a 17 cubic foot refrigerator, that's how much space it has in terms of interior volume. All right. And the last problem that I believe you may have in your notes, I don't have it listed for you on this document, but I think there's a problem in your notes that talks about a website that you can go to that helps you look at the current national debt. Even if you don't have that in front of you, that's not a big issue. If you want to go ahead and click on it, the national debt's such a big enough number that you definitely would want to use scientific notation to write it. Okay, this ends the 1.3 lesson plans.